Hi, my name is Camila and I'm going to I'm going to teach you how I solve my exercise. Here's my circuit, and we first identify all the loops that are inside the circuit. I already did that, so to save me time. Here's I1, I2, I3, I4, and because of this arrow over here and this direct current, we know that it's between here these two loops. We know this is a super mesh, and we start to do our equations. We also know that voltage is equal to resistance by current, and we know that all the sum of the voltages in a circuit is equal to 0. Therefore, we analyze each loop. We start with the first loop. The current is entering by the negative sign, therefore is -5, and then we sum 30 ohms multiplying I1, and we have a resistor then of 45, and here we multiply 45 by I1 minus I2, since when the current touches this resistor, well, here is like counterclockwise, and the arrows goes like down. Well, I'm going to put this go down, and when this current touch like passes through the resistors is going upwards, and therefore we know, and it's like not counterclockwise, therefore we know how to put the signs, and this is equal to 0. For the next loop, we are going to analyze I2. There's a resistor of 45 ohms, and that is also, we start to analyze I4 over here. Since the current is entering the positive sign, we put that is 7 volts. 7 volts plus 54, that is the resistor we have over there, that is multiplying I4 minus I2. This equals also to 0. And then in our super mesh, we have to analyze only the components that are on the perimeter of the super mesh. Therefore, our following equation is we start by our resistor of 45 multiplying I2 minus I1. Then we follow to the following resistor, that is plus 44 I2 minus I4, and then we have I have done this resistor, and now is this resistor, and since there is no like another loop besides like next to it, we say that 55 is equal, it's multiplying I3 only, and all of this equals to 0. Also, we have to establish that in our super mesh, the sum of these two loops is equal to this current right here in the middle, and we know that when this loop passes, that our current is going upwards, and when this loop is passing over here also goes upwards, but when I2 goes like it's passing through there, it's going downwards. Therefore, we know that I3 is positive and I2 is negative. Therefore, we say I3 minus I2 equals to the current that we have over there, that is 1/4. And we solve our system equations. We start to simplify them, and we start to multiply everything that we have in our equations. Plus 45 I1 minus 45 I2. All of them we have to multiply it so we can rest and sum. Menos 54, no. 45 I2 menos 45 I1, 54 y 2 menos 54 y 4. 55 y 3. Well, after multiplying everything, we get this equation, and we start to input it in our calculator. Sorry, it's dropping. We go to home, home and equation. We input simple equation for unknowns, and we start to input our equation right there. -45 y esto es igual a 5. Okay, now that we input it in our calculator, we click OK, and it starts. I chose like X was my I1, Y was my I2, Z it was my I3, and therefore T was my I4. And my calculator gives me that I1 it's equal to 157 over 4,380. And then my I2, it's equal to minus 15 over 292. My I3, it's 29 over 146. And lastly, my I4, it's 617 over 7,884. And then we have all our currents, and also the exercise asked me to get Bx, and as I stated in the beginning, B is equal to R by I. So our Bx is right here, yes, and therefore our Bx is equal to the resistance that is over there, that is 45 ohms, multiplying I2 minus I1. Yes, I2 minus I1. No, I1, since it's entering the positive, I1 minus I2. And we already have I1 and I2. Well, after multiplying, we have that Bx is equal to 573 over 145 volts. And lastly, is asked to do the power, and our power, it's equal to our resistor, multiplying our current. Yes, it is. Yeah. Okay. Okay. Sorry, I was mistaken. It's current by our voltage. P equals to I with P. Okay, and to get our B in our super mesh, we get estoy marcando voltage is equal to resistance to current, and then we multiply this resistance to this current. 55 414 55/4, and then our P. So there, then multiply our current, that is 1/4, by our voltage, that is 55/4. And we get that our power is 55/4 watts. And that's it. Thank you.